Okay, so we're going to consider a 7 by 7 matrix. And not only are there numbers in the matrix, but there are variables in it as well. Okay. So in order to do that, we'd have to construct seven matrices that are 6 by 6. Each of those 6 by 6 guys would have to construct 6 matrices that are 5 by 5. Each of the 5 by 5s would have to construct 5 4 by 4s. Each of the 4 by 4s would have to have 4 3 by 3s. So how many 3 by 3s do we have? 4, 20, 120, 120 times 7. 800 and whatever, right? 840. Okay, so 800. So I'd have 840 3 by 3s to solve this problem. Now, with a couple zeros in there, that'll help out, right? All right. This particular problem I did as a junior in a math class at Michigan State. It took me 3 weeks. It was a take-home test, take-home final, and it was 35 pages of handwriting to get to that position. All right. Anyway, so clearly we're not going to have to do that. All right, so that is all that this is about. So, but yeah, 35 pages, and that was not in my big handwriting either. That was in my small handwriting. And there were plenty of mistakes made along the way that I had corrections. I got a B in the class. I never got the test back. I don't know whether or not, you don't get your finals back, so I never knew whether or not I had it right. Okay, so we're going to do problem number 3. Oh, your calculators do this. Yeah, on the math button, there's the matrix button. So a second function matrix, and you would enter the matrix, and then you do the math on the matrix, which you notice the first one is a determinant. So I'm going to do this guy by hand first, and then I'm going to put them in my calculator and see if I can get the same answer. So I got 2 minus 3 minus 4, 5. You paid $20 for this calculator. Of course it can do determinants. I mean, give me a break, you know. All right, so 2 times 5 is 10, minus a minus 12. So the answer should be minus 2. All right, so I'm going to take my calculator. I'm going to go second function, the matrix key, which is very close. So second function matrix, and I'm going to go to edit. So, and I'm on A, so I'm going to go to edit, and I'm going to go enter. Okay, so A has how many rows? It has 2 rows. It has 2 columns. 2 columns. And I hit OK. Okay, now I put them in. I put in a 2 for my first entry and a minus 3 for the next guy, and the next guy gets a minus 4, and the next guy gets a 5. Okay, so now I have my matrix and it's entered. Second function, escape. And second function, quit. Second function, quit. And now I'm going to go second function, matrix. Second function, matrix. I'm going to go to math. And then I'm going to hit enter, and I get determinant. Now, I have to put an A there. So now, how do I get an A there?
Second one.
No, that's not how I get an A there. Second function 1. Second function 1. All right, so I go I hit determinant, and then I get second function 1 for the A. I close the parentheses. Syntax error. Shit. You got make it -2? Okay.
Yeah. When you hit determinant, go back in to matrix.
Oh, okay, right, exactly. Clear. Okay, second function math. Okay, I go to determinant, but then I go second function matrix A. Okay, there we go. That's right, -2. All right, so you don't do second function 1 to get an A because that's the A for hexadecimal numbers. You want second function matrix A. Okay, excellent. So we did that. We made our calculator get -2, and I got -2. All right, excellent. Number 17. Well, I guess this is good. Now, my calculator won't do this one because I can't put variables in and ask it to do a numerical thing. So m n minus a minus making it plus n cubed. Oh, could it be any easier? 20. Two, 0 minus 6, 4 minus 1 minus 7, minus 3, 3, 2. All right. Now, you can write the column and row over again, or you can remember that it's there. So I'm going to write it over again, but normally I wouldn't do that. I just remember that it was there. All right, so I got 2 times minus 1 times 2. That looks like minus 4. Plus a 0. And then I've got 24 times 3, which is 72, minus 72. And then going the other way, minus, 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 minus makes a minus. Minus 18. 42, minus 42, and then plus 0. Okay, so that's what I have. So I've got minus 76 plus 40, 50, 60. So I should get a minus 16, should be my answer. All right, so I go back to my calculator, second function, matrix, edit, and I'm going to use A again, so I'm going to have a 3 by 3. Notice I can't go to 4 by 4s or 5 by 5s or 6 by 6s. Dumb calculator anyway. So I've got a 2, a 0, a minus 6, a 4, a minus 1, a minus 7. I've got a minus 3, a 3, and a 2. Okay, second function quit, second function matrix, go to math, determinant, second function matrix, the A guy, and I got minus 16. So my calculator says minus 16, and my math, my adding and subtracting said minus 16. So I'm perfectly happy with minus 16. 36, you gotta be kidding me. Oh, that's not hard though. I can do 36. Anybody want to go to the board and do 36 for me? Anybody want to go to the board and write 36 on the board? Okay, so what we'll do is we won't write down the original matrix. We're going to expand on the row where all the zeros are, except for that 1, 2. Okay, so that's the plan. So I've got 0 plus minus 1 raised to the row 1, 2, 3, 4 plus column 5, 6 times the 5 by 5 that's left over, removing that row and that column. minus 1, 3, minus 2, 6. 5, 0, minus 3, 0. 6, 0, 1, 1. 2, minus 1, 1, 2. Okay, plus 0, plus 0, plus 0. 1, 2, 3, 4, 5 things. 1, 2, 3, 4, 5
Your
things.
first one on that matrix, shouldn't that be a one?
No, that's a minus 1.
Oh, there
Right
is
there?
minus one. Because your minus one is
Oh,
your
there's
first
a 2 here. There's a 2 there.
5, 6, 2. I didn't hang with 1.
1. This is a minus 1. Yeah, the first guy's a minus 1.
I thought if it was in the first column, you didn't use that first number.
But the column we're removing is the column and row the 2 is in.
Okay, I understand.
Okay, so I'm removing the column and row the 2 is in. Okay, well, now minus 1 to the 6 is 1. Okay, so that just is a 1. I'm now going to expand on this guy right there because I have the most zeros. Okay, so I've got 2 times minus 1 row plus column. 2 plus 1 is 3 times what's left over. So I remove that and end up with a 5, 6, 2 minus 3, 1, 1, 0, 1, 2. And then I've got this minus 1 down here, so plus a minus 1, the row 1, 2 plus column 3, 4, 5, 6 times minus 1, the element itself, and then I'm getting rid of that guy and that guy, and what I have left over is a minus 1, 5, 6, minus 2, minus 3, 1, 6, 0, 1. All right, so now I've taken my 5 by 5 guys and turned it into 2 3 by 3s because I have a whole lot of zeros and life just got a whole lot better. So I'm going to have 2 times minus 10, 0, minus 6, minus, going the other way, 0, 5, minus 36. Plus, that's a minus, that's minus 1 of 6 is 1. So I'm still going to have minus 1 times, I have a 3, I have a 30, I've got a 0, minus, I've got a 36 times 3. 36 times 3, 108. So I got a minus 108 plus 0, and then this guy's going to be a minus 10. All right.
Before you move on, after the 2, it's a negative. Your negative right there, it should be multiplied by 3. I believe. No, like
Yes,
here.
yes, I agree. So there's a 3 sitting there, and there's a 3 sitting here. All right, and now my negative sign is pretty weird. Okay, excellent, thank you, Ben. Okay, so I got 2 times minus 3 times. That's a 4. A 4 plus a 31 is a 35. Minus, I've got 33 minus a minus, 33 minus a minus 118. So it'd be a 1, 5, 1. 1, 5, 1. And it'd be plus, I think. Really? 33 plus 108 plus 10. Yeah, 151. Okay, so I got 151 minus 3 times 35. So I got 2 times 46, and then times 2, 92. So that guy should be a 92, all things being equal. Unless I made some other mistake along the way. Now, we can't put the 5x5 or the 4x4 in our calculator, but we certainly can put each of these 3x3s in the calculator. All right. So now we're proceeding to section 6-5. And we see that determinants have properties. And those properties should help us find the number for the determinant if we're so lucky. So if a row of a determinant is all zeros, or the column of a determinant is all zeros, then the determinant is going to be 0. So that's just the way that is. If I have 2 rows or 2 columns, so I have 2 rows, or I have 2 columns that are the same, then my determinant's going to be 0. If I change any 2 rows or any 2 columns, the only thing that gets changed is the sign of the determinant. So if I'm going to switch 2 rows, I switch 2 rows, or I switch 2 columns, then the sign, S-I-G-N, is going to change on the determinant. So if I had plus 2 originally, then I'm going to be minus 2. All right, so let's try that. I got 1, 2, 3, 4. All right, so I got 4 minus 6, 4a minus 2. And I'm going to change it 4, 3, 1, 2. And now I got 6 minus 4 for a 2. Okay, if I go 2, 4, 1, 3, I'm going to have 6 minus 4 for a 2. So if I switch 2 rows, now why would I do that for? I probably wouldn't, but if I did, that's what would happen. I can go, if I have something that looks like 2, 4, 6, 8, 10, 12, 14, 16, 18. And I want that determinant. Then that determinant would be the same as if I took a 2 out and multiplied it 2 times 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can factor out something out of every component if I have a common factor, and I'm going to have the same determinant. If every row or every column is multiplied by the same number k, the resulting added to another column, the thing stays the same. Okay, so this is a little more weird. So I've got A, B, C, D. And that's going to be AB plus CD. Oh, yeah, it's not shit. AD minus BC. All right, so what I'm going to do is I'm going to multiply this guy by K. And then I'm going to add that row to that guy. Now, why would I do such a stupid thing as that anyway? Well, we won't know that until we get later on in the chapter, but there's a reason for doing it. And it says that if I do that, my value of the determinant is going to remain the same. All right, so I've got A, B. I've got A, K plus C. I've got B, K plus D. And I find the determinant. And it better be the same as that, otherwise we'll have to throw the book away. All right, so I've got, multiply that one. A, B, K plus A, D minus A, B, K plus B, C. Okay, is that what I got? All right, I got one of those minus one of those, and then all I got left over is AD minus BC, which is the same thing I had before. Okay, so it must be true. So I have 5 properties of determinants. Now we're going to go and use those properties to solve problems. So we'll look at number 4. Number 4. Are we even going to write it down? 6, 5, 0, minus 9, minus 3, minus 4, 0, 2, 2, 3, 0, minus 7, 7 minus 1, 0, 12. I have a row, I have a column. I have a column that's all zeros. The determinant is 0, thus it is done. Okay, good enough? No. Hey, it should always be that simple, right? 24.
There's a reason you picked that one, huh?
Yeah, I picked that one on purpose. So. Well, I don't know. I'm looking at 24 and I'm thinking I have no clue. Luckily, we'll run out of time before we get number 24 done. Okay, so I got 2, 2, 3, 5, minus 7. 3 minus 6, 9, 12, 15. 4 minus 5, 3, 7, 2. 2, 0, minus 4, 2, 7. 3, 3, 4, minus 3, 3. All right. Luckily, we know we're in section 6-5, so that'll give us some clue. And I don't see a column or a row that's all 0. Does anybody see that? No. I don't see a column or a row that are the same as some other column or some other row, right? You don't see that either, right? All right, well, that being the case, and I don't see enough zeros to make it worth my while to do the problem yet. Okay, so those are the 3 issues that are involved here. what are we going to do about it?
Got your answer.
Oh, yeah? Yeah, with a fancy enough calculator. What's the answer?
32562.
32562. Yeah, sure. What a pain in the butt.
Yeah, that's what I got too.
Yeah, I can imagine.
Some kind of-
That's why I wrote it down.
All right, what we're going to do, I'm going to multiply this guy times 2, and I'm going to subtract it from that guy. And then I'm going to take this guy and subtract it from that guy. No, that's what I'm going to do. Okay, so I keep the top guy, 2, 2, 3, 5, minus 7. Multiply by 2 and subtract. 0, I like zeros, minus 9. No, don't want to do that yet. I want to write down, I'm going to run out of room. Okay, I'm going to write down the next guy. 3 minus 6, 9, 12, 15. All right, so 0 minus 9 minus 3 minus 3, 16. Okay, now how am I going to get this without being able to see it? 0 minus 2, 0 minus 2, 0 minus 2, minus 7 minus 8, minus 7 minus 8, 14. And then I've got a 3, 3, 4, minus 3, 3. Okay, so I got that. All right. If I go and take this guy and subtract him from that guy, if I were to do that, actually I got a 2, 2, 3, 5, minus 7, 3, minus 6, 9, 12, 15, 0, 0, 0, minus 9, minus 2, 9. Minus 5, minus 3, minus 7, minus 5. Minus 3, minus 8, minus 15. 16, 14, minus 12. Okay, well, if I were to go and take that guy and just add him to that guy, I'd have a 2, 2, 3, 5, minus 7, 3, minus 6, 9, 12, 15, 0, minus 9, minus 3, minus 3, 16, 0, minus 2, minus 7, minus 8, 14, 0, 0, minus 8, minus 18, 4. All right, any more low-lying fruit? do I have enough zeros to solve it yet? That's the issue. And when I get to the point where I think I have enough zeros to actually solve it, then I would go and solve it. I think I'd do it one more time. I think I would take these guys and add 2, 0, minus 4, minus 3, 7. 3 minus 6, 9, 12, 15. 0 minus 9 minus 3 minus 3, 16. 0 minus 2 minus 7 minus 8, 14. 0, 0 minus 8 minus 18, 4. Okay. I think at that point I would expand around that guy, because that would give me 3 zeros that way. And then I would probably continue what I'm doing to get more zeros in there. But clearly I ran out of time, so that's as far as I go. But that's what I would do. I'd keep on simplifying it. I wouldn't try to go in without a whole lot of zeros to use. And in fact, gee, why can't I just get rid of one? I could get rid of another one. I could multiply this times 3 over 2 and subtract, but now I have fractions. And I'm not sure I want to do that. So I probably wouldn't. I'd probably expand it there. But I could go and multiply this times 3 and add to there, and that would make that guy a 0. And that might help out. So I could do something cool like that if I wanted to. Anyway, luckily we're out of time, so we can call it a day.